Hello dear students, Assalamu alaikum. I hope you will be fine. My name is Engineer Nirmazul Shah. I am lecturer in Department of Technology, Sarhad University of Science and Information Technology, Peshawar. Subject I am teaching you is Design of Hydraulic Structure, and today is your lecture number 10. In lecture number 10, we will solve the example related to Kozla method of independent variables. The statement of the example is to determine the percentage pressure at various key points in the figure below. Also determine the exit gradient and plot the hydraulic gradient line for pond level on upstream and no flow on downstream. So in this example, we have to find the percentage pressure at various key points such as E1, D1, EC1, E2, D2, C2, E3, D3, C3. Since these are the key points, and we have to find the percentage pressure at these key points, and also we will find the exit gradient and plot the hydraulic gradient line for pond level on upstream and no flow on downstream. The pond level on the upstream, the reduced level on the upstream side, the pond level of the reduced level of pond is given, which is 158 meters. These readings are in meters. The reduced level of the floor is 154 meters, while the reduced level of the upstream sheet pile line is 148 meters. Similarly, the reduced level of intermediate pile is 148 meters, while the slope is 1:3 at C2, and the reduced level at the end of slope is 155 meters. The downward slope is 1:5, and the reduced level at the end of the downslope is 150 meters. Similarly, the reduced level of sheet pile at the downstream side is 141 meters, and the top reduced level is 152 meters on the downstream side. The thickness of the floor on the downstream side is 1 meter. Similarly, on the downstream side it is 1.3 meters. The total weight V of the structure is 57 meters, while the distance between sheet pile line 1 and 2 is 15.8 meters, while that of the distance between sheet pile number 2 and 3 is 40 meters. In solution, first of all, we will find the percentage pressure at key points on the upstream pile line number 1. The total length of the floor B is 57 meters, which is already given in figure. Depth of upstream pile line D is equal to 154 minus 148, which is equal to 6 meters. The reduced level is 148 at the bottom and 154 on the top. So by subtracting 148 from 154, we get the total depth of the sheet pile on the upstream side, which is equal to 6 meters. Now we will find alpha, which is equal to B divided by V, which is the ratio between the total width of the structure divided by depth of the sheet pile on the upstream side. So B is equal to 57 meters, which is already given, and also D is equal to 6 meters, which is already find out. So alpha is equal to 9.5. Now we will find 1 over alpha. So 1 over alpha is equal to 1 over 9.5 and is equal to 0.105. Now from curve 11.1a, the phi E value is equal to 29. As you can see, the red line here is, this point is equal to 0.105, and this is the value of 1 over alpha. So using the value of 1 over alpha, coming to the curve, take the value of, select the value of 0.105, and coming to the curve, this is the curve of phi D and this is the curve of phi E. So the formula for phi C1, which is the pressure at percentage pressure at C1, is equal to 100 minus phi E, and the percentage pressure at D1 is equal to phi D1 is equal to 100 minus phi D. So we will find the value of phi E and phi D from this curve using the value of 1 over alpha equal to 0.105. So on graph, the value of 0.105 is here, and coming to the curve phi D and phi E, the value of phi D is equal to 29. The value of phi D is equal to 20, while the value of phi E is equal to 29. So putting these values in these equations, we will get the value of phi C1, which is equal to 71%, and phi D1 is equal to 80%, while phi E1 is equal to 100%. Since E1 is the entry point, and at the entrance point the percentage pressure is maximum, so automatically take phi E1 equal to 100%. At phi D1 the percentage pressure is 80%, which is find out through this equation, and the percentage pressure at phi C1 is equal to 71%, which is find out through this equation, which is phi C1 is equal to 100 minus phi E, and phi D1 is equal to 100 minus phi D. These are the equations which are given by the Gauss law method of independent variable for a simple profile. Now we will apply correction at phi C1. So correction required at phi C1. First of all, we will find the correction or do correction at C1 for mutual interference of pile. Since the correction at C1 for mutual interference of pile phi C1 is affected by intermediate pile number 2, correction C is equal to 19 under the root D divided by B dash into B D divided D plus capital D divided by B. This is the formula for correction due to mutual interference of pile. Here D, capital D, is equal to depth of pile number 2. So depth of pile number 2 is equal to reduced level of top minus reduced level of bottom is equal to 5 meter. These values are already given in figure. As you can see, the bottom reduced level is 154 and the top reduced level is 153. So 153 minus 148 will give you the depth of sheet pile number 2. This is sheet pile number 2, which is equal to 5 meter. Small d is equal to depth of pile number 1. So depth of pile number 1 is equal to 153 minus 148. Again, this is the reduced level of top and this is the reduced level of bottom of sheet pile number 1. And the depth of pile number 1 is equal to 5 meter. Similarly, B dash is equal to distance between two piles, that is equal to 15.8 meters. Also given in figure, the distance between sheet pile number 1 and 2 is equal to 15.8 meters. So this is the value of B dash. Also B is equal to total floor length equal to 57 meter, and this is also given the total floor length is 57 meter. So putting all these values in this correction equation, we will get the value of correction for phi C1 is equal to 1.88%. Since the point C1 is in the rear in the direction of flow, the correction is positive. So therefore correction due to pile interference on C1 is equal to 1.88% is positive. Now we have to find correction due to thickness of the floor. So correction due to thickness of the floor, CT, which is correction due to thickness of the floor at C1, is equal to T1 into phi D1 minus phi C1 divided by D1. Here phi D1 is equal to 80% and phi C1 is equal to 71%. Already find out phi D1 80%, phi C1 71%. Also D1 is equal to 154 minus 148. 154 is the reduced level of the top of sheet pile number 1 and 148 is the reduced level of the bottom. So subtracting 154 minus 148 will give you the total depth of sheet pile number 1, and subtracting 154 minus 153, the reduced level of the top and reduced level of the bottom of the floor will give you the total thickness of the floor. So total correction due to thickness of the floor is equal to 1.5%. Now in number 3 we will find the correction due to slope at C1, and the correction due to slope at C1 is equal to 0 since there is no slope at the starting or end of at C1 point. So hence corrected phi C1 is equal to computed phi C1 plus corrections. So computed phi C1 is equal to 71%. Already find out this is the computed phi C1 plus the corrections. So the corrections are plus 1.88%, which is the correction due to mutual interference of the pile, and plus 1.5, this is the correction due to thickness of the floor. Both these corrections are positive, so add these corrections with computed phi C1, we will get the corrected phi C1 equal to 74.38%. So this is the corrected phi C1 value, or corrected percentage pressure at C1. Now for intermediate pile line number 2, D is equal to 154 minus 148 equal to 6 meter. This is the total depth of sheet pile number 2. This is the reduced level of the top, this is the reduced level of the bottom. B is the total width of the structure already given. So finding alpha is equal to B divided by D equal to 57 divided by 6 equal to 9.5. We have B1 in this case. B1 is equal to 0.6 plus 15.8 equal to 16.4 meters. Here, as you can see, B1 is 15.8 meters and the thickness of this sheet pile line is 0.6 meter. So adding 15.8 with 0.6 will give you the total B1 value, which is 16.4 meters. B is equal to 57 meter. Now finding B1 divided by B is equal to 16.4 divided by 57 is equal to 0.298, and this value should be used for finding the value of phi C2. Also B2 is divided by B is equal to 1 minus B1 divided by B. Since the sum of ratios is equal to 1, so subtracting the value of B1 by B from 1 will give you the value of B2 divided by B, which is equal to 1 minus 0.298 equal to 0.702. So this is the value of B2 divided by B. Now using curves of plate 11.1B, which is this one, we will find the value of phi C and phi D. The equation for phi E2 for finding the percentage pressure at E2 is equal to 100 minus phi C, while to find the percentage pressure at phi D2 is equal to 100 minus phi D. So finding the value of phi C using V1 divided by V and alpha is equal to 9.5, this is the value of alpha 9.5, and this is the value of B1 divided by B, which is 0.2, which is 0.298. We will find the value of phi C equal to 56. So this is the value of phi C2. I will zoom it, then we will get a clear idea of it. This is the value of phi B1 divided by B, which is 0.298. So coming to the curve, these are the curves of phi C. So coming to the curve, alpha value 9.5, joining this to the 9.5 and coming here, we will get the value of phi C, which is 56%. Also using the value of B2 divided by B, which is 0.7, I think so, 0. It is coming here again. I zoom out it, you will get a clear value, which is B2 divided by B is equal to 0.702. So using this value, we will find the value of phi D. This is the curve of phi D. Again, I will zoom it. This is the curve of phi D. Clear? So coming to the value of alpha 9.5, it will come out to be here, and this is the value of phi D, which is 37. Also the value of phi C for B2 divided by B is 30. So using the equations for intermediate sheet file is phi E2 is equal to 100 minus phi C, and for phi D it is 100 minus phi D. So the value of phi C is 30 using B2 divided by B. So phi E2 is equal to 70%. Phi C2 is find out directly by using B1 divided by B2, which is 0.298, and it comes out to be 56%, while phi D2 is equal to 100 minus 37, and 37 is the value of phi D, which is find out from these curves, using these curves, and it is equal to 63. So through this way we will find the different percentage pressure using this curve. Now we will apply corrections for phi E2. The correction at E2 for sheet pile number 1 will affect the pressure at E2, and since E2 is in the forward direction of flow, this correction shall be negative. The amount of this correction is given as correction is equal to 19 in under the root D divided by B dash into D plus capital D divided by B. Here capital D is equal to depth of pile number 1, the effect of which is considered is equal to 153 minus 148 equal to 5 meter. Small d is equal to depth of pile number 2, the effect on which is considered 153 minus 148 is equal to 5 meters. B dash is the distance between the two piles, which is 15.8 meters already given in figure, and B is equal to total floor length equal to 57 meters. All these values are given in figure. So taking these values from figure and putting these values in this correction equation, we will get the correction for E2 is equal to 1.88%, which is negative. Since the E2 is E2 for sheet pile number 1, the effect of pressure at E2 is negative since E2 is in the forward direction of flow. Now we will find the correction at E2 due to thickness of the floor. So using the correction due to thickness of the floor at E2 is equal to T2 into phi E2 minus phi D2 divided by D2. Phi E2 is equal to 70%, phi D2 is equal to 63%, D2 is equal to 154 minus 148, which are the reduced levels. So subtracting 154 minus 148 will give you the total depth of D2, and T2 is equal to 154 minus 153, which is the thickness of the floor. So total correction due to thickness of the floor is equal to 1.17 at E2. Similarly, the correction due to slope at E2 is equal to 0 since no slope starts or ends at E2. So hence the corrected phi E2 is equal to computed phi E2 plus corrections. So computed phi E2 is already found out that at the end it is 70% minus the correction due to mutual interference is minus, so minus 1.88%. Also correction due to thickness of the floor is minus, so minus 1.17%. So hence corrected phi E2 is equal to 66.95%. Now the correction for phi C2, corrections at C2 due to pile interference, pressure at C2 is affected by pile number 3, and since the point C2 is in the back water in the direction of flow, this correction should be positive. The amount of this correction is given as by correction equation, which is 19, correction equal to 19 under the root D divided by D dash into D plus capital D divided by B. The values of D is equal to, the value of D is equal to depth of pile number 3, the effect of which is considered below the level at which interference is desired. So to find the depth of pile number 3, we have the reduced level of pile number 3. The top reduced level is 153 and the bottom reduced level is 141.7. So subtracting 153 from 141.7 from 153, we will get the total depth of sheet pile number 3, which is 11.3 meter. Also small d, depth of pile number 2, the effect on which is considered is 153 minus 148 is equal to 5 meters, and B dash is equal to distance between the two piles, which is 2 and 3, sheet pile number 2 and sheet pile number 3 is equal to 40 meters, also given in figure, and total width of the floor B is equal to total floor length is equal to 57 meters. So putting these values in the correction equation, we will get the correction for phi C2 is equal to 2.89%, and this is positive since C2 is in the rear or back side of water, or in the back direction of flow. Also correction at C2 due to thickness of the floor, CT into C2 is equal to T2 into phi D2 minus phi C2 divided by D2. Phi D2 is equal to 63%, phi C2 equal to 56%, so 63 minus 56 divided by 154 minus 148 will give you the total depth of D2, and 154 minus 153 will give you the value of T2 equal to 1.17%. So this is the correction value due to thickness of the floor. Also the correction due to slope at C2 is equal to, since the point C2 is situated at the start of the slope of 3:1, that is an up slope in the direction of flow, so the correction should be negative. Also the correction factor for 3:1 slope from table, which is already given in lecture number 9. The correction factor for slope 3:1 is equal to 4.5. The horizontal length of the slope is 3 meter, already given in figure. This is the horizontal length of the floor, 3 meter, and the slope at the C2 is at the start and it is in the upward direction. Distance between two pile line between the sloping floor is located equal to 40 meters. So actual correction is equal to 4.5 multiplied by 3 divided by 40 will give you the total percentage correction value, which is equal to 0.34% and is negative since the slope is in upward direction. So hence corrected phi E2 is equal to computed phi E2 plus corrections. Computed phi E2 is 56%. The correction due to thick mutual interference is 2.88% and it is positive. Also, the correction due to thickness of the floor is positive and its value is 1.17, while the correction due to slope at C2 is negative since the slope is in upward direction and its value is minus 0.34%. So the corrected percentage pressure at E2 is equal to 59.72%. Now we will find the percentage pressure on the sheet pile line number 3. T is equal to 152 minus 141.7. 152 is the reduced level of the top and 141.7 is the reduced level of the bottom, already given in figure. So total depth of sheet pile number 3 is equal to 10.3 meter. B is equal to 57 meter, already given. So 1 over alpha is equal to 10.3 divided by 57 equal to 0.181. Now using this value, this 1 over alpha value, and using curve of plate 11.1a, we get phi C3 is equal to 0, phi D3 is equal to 26% and phi E3 equal to 38%. This is the value of 1 over alpha, which is 0.181. Coming to, this is the curve of phi D, coming and joining this to phi D curve, and you will get the value of phi D, which is 26%. So this is the value of phi D3 equal to 26%. Now using this value 1 over alpha value, which is 0.181, and coming to curve phi E, we will get the value of phi E3 equal to 38%. And the percentage pressure at phi C3 is equal to 0%, since this is the exit point or end point. So we have already studied that at the start the percentage pressure is maximum and is 100%, while at the end it is a minimum, the percentage pressure is minimum and is 0%. Now here the correction required at phi E3, first of all we will find the correction due to mutual interference of pile. The point E3 is affected by pile number 2, and since E3 is in the forward direction of flow from pile number 3, this correction is negative and its amount is given by correction is equal to 19 under the rule capital D divided by B dash into small d plus capital D divided by B. Capital D is equal to depth of pile number 2 and is equal to the effect of which is considered equal to 150.7 minus 148 and is equal to 2.7 meter, while the depth of pile number 3, the effect on which is considered equal to 150 minus 141.7 equal to 9 meters. Also B dash is equal to distance between the two piles is 40 meters and small b is equal to total floor length equal to 57 meters. So putting all these values in this correction equation, we will get the correction value equal to 1.02%, and this value will be negative since E3 is in the direction of flow. Also the correction due to thickness of the floor, Ct into E3 is equal to T3 into phi E3 minus phi D3 divided by D3. phi E3 is equal to 38% and phi D3 is equal to 26%. I already find out. D3 is equal to 152 minus 141.7 will give you total depth of D3. This reduced level give you the total depth of D3, and the thickness of the floor is equal to 1.3 meters. So simplifying all these values, we will get the total percentage pressure or the total corrected thickness due to, or total corrected value due to thickness of the floor equal to 1.51%. Also, correction due to slope at E3 is equal to 0, since no slope starts or ends at E3. Hence, corrected phi E3 is equal to computed phi E3 plus corrections. So, computed phi E3 is equal to 38 minus 1.02%. This is the value of correction due to mutual interference, minus 1.51%, and this is the value of correction due to thickness of the floor. So subtracting these values from computed phi E3, we will get the corrected phi E3, and it is equal to 35.47%. So the corrected percentage pressure or coefficient at various key points are tabulated below in table. On the upstream pile number 1, the percentage pressure at E1 is equal to 100%, since this is the entry point, and at the entrance point the percentage pressure is 100% or maximum. The value of phi D1 is 80%, while phi C1 is equal to 74.38%. Similarly, intermediate pile number 2, phi E2 is equal to 66.95%, phi D2 is equal to 63%, and phi C2 is equal to 59.72%. Similarly, on the downstream pile number 3, phi E3 is equal to 35.47, phi D3 is equal to 26%, and phi C3 is equal to 0%. Since this is the end point, and at the end point the percentage pressure is minimum or 0. Now at the end we will find the value of exit gradient. Let the water be headed up to the pond level, and the reduced level of the pond level is given in figure, which is 158 meter on the upstream side and no flow on the downstream side. The maximum seepage head H is equal to 158 minus 152 equal to 6 meter. The depth of downstream cutoff pile D is equal to 152 minus 141.7 equal to 10.3 meters, and total floor length B is equal to 57 meters. So finding the value of alpha B divided by D, alpha is equal to 57 divided by 10.3 equal to 5.53. Now using this equation, first of all find the value of lambda, and lambda is equal to 1 plus under the root 1 plus alpha square divided by 2, and alpha is equal to B divided by D, and alpha is equal to 5.53. Putting this value in lambda equation, we will get the value of lambda, which is 0.18, and H is equal to 6, and D is equal to 10.3. We will get the value of GE, which is exit gradient, equal to 0.105. Hence the exit gradient shall be equal to 0.105, that is 1 in 9.53. So this is very much safe value. Also, you can find the value of 1 over pi under the root lambda by using the value of alpha. So alpha is equal to 5.53, and this is the value of 5.53. This point is equal to 5.53, and this is the curve of 1 over pi under the root lambda. Clear? So joining this point to this curve, we will get the value of 1 over pi under the root lambda and equal to 0.18. So simply putting this value in the above equation, GE equation, we will get the value of GE. And this is the end of today's lecture.